Good morning, good afternoon, good evening, everybody. My name is Kun Chen from Changqing Oilfield Company, China Petroleum Corporation. I'm honored to give a speech here. My topic is high-inclination coring of Chang-63 of Yanchang Formation in Huaqing Oilfield, Ordos Basin, implications for the paleocurrent direction and fracture orientation. High-inclination well is a well that crosses oil and gas target zone at a large angle in the oil development. Such drilling can not only reduce the blocking of the mudstone interior, effectively utilize the gas and the oil and gas reserve, but also effectively stagger the position of fraction transformation and reduced interlayer interference in the development of thin oil layer. Practice have proved that this drilling method can significantly increase the oil and gas production in the tight oil of thin deep water sandstone. Our oil field development zone is located in the Ordos Basin. Ordos Basin is the second largest inland basin in China, located in the north of the central China. During the Triassic Yanchang Formation, river, delta, and lake deposits were widely developed in the Ordos Basin. Huaqing Oilfield, our study area, is located in the sedimentary center of the Ordos Basin. The gravity sandstone extends the semi-deep and deep lake and vertically connects with Chang-7 source rock. Even the tight sandstone with poor physical properties become oil-rich due to the strong hydrocarbon injection. The massive sandstone of sandy debris flow in the Chang-63 layer is the most promising target in the exploration of gravity flow reservoirs, which is the thickest with the best oil barrier property. However, the prediction accuracy of the distribution direction of deep lake sandstone affects the exploration and development of such tight reservoir. Last year, we carried out continual coring of 105 meters in the high inclination well. We found that the cross-section of the core is in good agreement due to its dense lithology. Most cores are easily spliced. The flame structure indicates up-down direction, and we can get a horizontal rotating surface. In addition, because the core can only rotate coaxially with the coring barrel, we can obtain an inclined rotating surface according to the process drilling parameters. Two rotating surfaces in different directions can easily reset the core, similar to the working principle of zero position. Because there are a large number of load casts, flute casts, and groove casts in the deep water sandy debris flow, the paleocurrent direction is easy to be reconstructed after the core is reset. It is worth note that in the reconstruction of paleocurrent direction, the load cast and the large-scale flute cast are more important than the small-scale flute cast and the groove cast because they are often related to the main paleocurrent direction. In addition, there are two main kinds of fractures in the core. Large high-angle fractures are often filled with calcite, and small low-angle fractures are often developed in the massive sandstone distributed along the lithology interface. Our research results are as follows. The zoological histogram shows that the paleocurrent direction changed gradually from southwest, south to the west and the northwest. The arrow with different colors are the paleocurrent direction reconstructed by different body plan structure. The red arrow are the paleocurrent direction reconstructed by the lode-cast and the large-scale flute-cast. They are developed in the mudstone interbedded with massive sandstone, indicating that we have a great probability to find a more massive sandstone in the northwest direction of the study area. Another result is that most of the major features are mainly northeast by east, and a few of them are north-south. The deployment and the development well pattern should give priority to the northeast and east trending features. The paleocurrent direction of the sandy debris flow are highly consistent with the thickness map of sandstone, which was drawn under the restriction of several hundred wells from the thickness map. From thickness map, we can also see that the main paleocurrent direction in the northwest reconstructed by us is different from the large-scale provenance direction in the northeast, reconstructed by the predecessors using heavy minerals. If the drilling or deployment in the northeast, according to the large-scale provenance direction, we would suffer heavy losses. Therefore, high-inclination coring can significantly reduce the number of exploratory wells failures. In addition, we have drawn more than 200 wells around the study area this year. The drilling result in the first 4 months shows that the drilling ratio of sandstone in high inclination section of the drilling in the northwest is the highest. Therefore, I'm convinced of our research result of high inclination coring and think the high inclination coring has a broad application prospect in the research of deep water sandy debris flow. Finally, another research result is that we compared with burial history and the data of flute inclusion, believe that the large loss is by its trending features are mainly formed by Yanshanian tectonic compression, where the north-south trending fractures were formed by the Himalayan tectonic compression. That's all. Thank you for listening.
Thank you very much, Kun Chen. It was a very clear presentation. I also have a question for you. The question is posed by Ella Jin, and it says, Mr. Chen, thank you for your fantastic presentation. However, the core orientation is evaluated by directional sampling, which is indicated by side cutting, end drilling, and directional printing. What are the advantages of high inclination coring comparing with traditional directional coring?
Okay,
so what are the advantages?
That's a good question. There are some problems with the using of oriented sampling. One is that the direction marking of our core surface is not clear when the core is too hard or too tight. One is that the coring machine is complex, bulky, and expensive, and it is easy to cause the whole wall collapse. The high inclination coring has several attractive features. The issue of unclear or damaged markup does not exist because the oriented markup is not required, and the machine need for the coring is consistent with the vertical coring machine, and the difficulty of coring is not significantly increased compared with the ordinary vertical coring. That's all.
Jin, is this answering your question? Oh no, you cannot reply. I forgot. Thank you very much for your reply. Let's see if we have some more questions coming in. I have a question from Zaan Job. He compliments you with your talk, and he said he's great seeing soul marks in a core. Did you happen to collect any CT scan data from the core? Or maybe some image log data from the well bore to correlate to the data you showed?
Yeah, we have further research plan, but the sorry, I can answer him after the speech.
Okay, okay.
If I direct the question, maybe I need to think for a while. Yeah.
Okay, that's no problem, because you can you will get these questions in your email, and you can reply to that also per email. Okay. But I have another question for you, and also Roberto Davila compliments you with your talk. He asks, are you using image logs to help the interpretation of bedding and fractures? Image logs.
Yeah, but the image log is expensive, and we can see the smaller fractures on the core than the image log. I think.
Okay.
Yeah.
Okay. Well, thank you very much.